1.
Hello, everybody. Can people hear me? I think we're live now. Welcome to Whip Your Data into Shape with Python and Pandas Reactor. So let's just make sure I can actually change my slides here. Okay, so I'm Dave Wade-Stein. I'm a senior instructor at a company called Develop Intelligence based out of Colorado. We are partnering with Microsoft on these reactors. This is actually the first time I've done a reactor virtually. I've done them live in person. Obviously, that's a much more desirable thing to do, but given the current situation, this is where we are. So I teach mostly corporate students, Python, machine learning, DevOps, etc. A bunch of different topics. I also volunteer and teach students who are incarcerated how to code in Python, with the idea that they get out into the world and get a job, and many have. So that's what I do here. Our goal today is to talk a little bit about data science, and manipulating data with Python and Pandas. It's kind of a wide net. This is a somewhat condensed version of some reactors that were done in the past that were really all day. And I think Microsoft is in the process of refining and recombining and changing them somewhat. But for today, we're going to talk about data and how we can manipulate data and so on. And before we do that, I thought we'd just talk about a little background about data science and machine learning. Part of the reason for that is, we have various backgrounds, very likely of folks in the room. And of course, if we were in a classroom together, it'd be a little easier to assess what your backgrounds are and what your interests are. But in this particular situation, that's a little harder to do. Hold on one second, I'm just missing one window that I would like to see if I can see here. Yes, okay, I see what happened. Yeah, we're just kind of getting familiar with all of the vagaries of virtual training here, so my apologies for that. But to start with, I just wanted to talk about the fact that data really kind of defines the world around us. We're going to talk a little bit about data science and machine learning and what they are, and then do some hands-on where we're actually manipulating data using Python and Pandas. And so one of the things we want to think about are just all the things that we can do with data, all the things that data has allowed us to do in the world so far. So I mean, this picture just shows things like helping doctors find tumors, in an MRI, maybe helping farmers increase their crops, help a blind person identify obstacles, and possibly reduce defects in the manufacturing process. I mean, really, data can be used for all of these things and many, many more. So this was just a sort of an introductory slide to make that clear. And the next thing is to just have an understanding, a basic overarching understanding of what data science is. Now it looks like there's a little typo there. That S is not where it's supposed to be next to statistics, but the basic idea is that a lot of us might be programmers, and that might be our expertise. If we combine that with some math, specifically statistics, and then ideally some domain expertise, that really the intersection of those three are data scientists. So the data scientists in an organization have some coding skills, often not a lot. They don't tend to be expert programmers or anything like that, because they're often cobbling together libraries and things to do their work, and they're not writing a bunch of algorithms and things like that. So they've got some coding skills, and they've certainly got some math skills to back it up. And then they're familiar with the domain in question, the domain of the company. And if we put those things together, we really have a data scientist. And it might also be worth briefly talking about the process of data science. The idea is that initially there's some project that we want to identify the objectives, like we want more customers, right? That would be a great thing. Or we want to know, how our customers look different in COVID than they did when they could come in person and things like that. So we have some objective, and then collect and review some data. And in the process of doing that, you might find out that maybe your objective or your understanding is actually incorrect, and you might go back and refine that. But after collecting some data, there's this preparation phase, and that's really what we're going to talk about today, sort of the cleaning and the manipulating of data. Those take a real long time, and I think people don't often understand that, which is the idea behind having these kind of reactors, so that people can understand what's involved. And I think actually one other interesting potential purpose of these reactors is to get people interested and excited about data science and machine learning, and potentially move into that field. So the last time I taught in person was in Tel Aviv in December, and that was quite a large room, 100+ people in there. And there were a number of folks who were really interested in moving into the data science space. They were either programmers or had some other technical job, had no real background in data science, and were interested in moving into that space. And the truth is that this is the time to do that, because the amount of data that we generate as a society continues to grow exponentially, and the number of data scientists we have, of course, does not grow exponentially. So there are lots and lots of openings and interest in that. But back to this, there's this data preparation phase, and then there's some manipulation of the data, some modeling. That would be actually the real machine learning that we're not going to get into today, but we can talk a little bit about what's involved there. And then evaluation. So how are we doing? How's our model actually doing in terms of making predictions about our customers or other, the weather or what have you. And so you see that at each of these stages, there's the potential to go back. It's very cyclical. So before you even deploy some machine learning model, you may do some evaluation and say, hey, this really doesn't work. We've completely misunderstood the problem, or let's change the data we're getting, and so on. So this is a very iterative and onerous process if you are, especially if you're expecting it to just be, ooh, let's do some machine learning and kind of pull the crank on a machine learning algorithm. What you find is that the results are not often what you expect. And so data scientists do a lot of this work repetitively to really get a good understanding of the business and be able to have some, say, machine learning tools that can actually do some real prediction. If you had to describe a data scientist in one phrase, I would say data scientists add value. So in any company, a data scientist's job is to add value. That could be adding more customers. That could be getting existing customers to spend more money. That could be restructuring product offerings so that profit goes up and so on. But in some sense, they're all about adding value to the company. And that's a fairly large umbrella, broad umbrella, but gives you an idea what's happening there. So then where does this fit in kind of to our worldview, data science specifically? We know that data science is a subfield of artificial intelligence, we could say. And one of the problems we have, I guess I shouldn't have gone to that slide so quickly. Whenever you mention the term artificial intelligence, immediately people think of Arnold Schwarzenegger and the Terminator and all of these ex machina and doomsday scenarios. So in classes like this, I always think it's good to have a shared understanding of artificial intelligence, at least as we want to frame it here. And this quote is a good one. Artificial intelligence is computers doing things we would normally think of as intelligent in humans. The only problem with this definition is the word intelligent is very difficult to explain, at least to people's satisfaction. I would even take out the intelligent and say artificial intelligence is often computers doing things that formerly only humans did. Think of playing chess or driving a car, right? Self-driving cars, or even a Nest thermostat properly adjusting the temperature so that you're comfortable in your home. You no longer have to do it. The thermostat will do that for you. The problem is, though, once you define it in those terms, which is often perfectly good for a course like this or an introduction like this, people say, well, that's not intelligent. That's just, kind of maybe labor saving, doing something for the human. And it brings us into this next quote, that artificial intelligence is just whatever a computer can't do yet. So, before a computer could do computer vision, before computers could drive cars, we considered that artificial intelligence. But when it becomes the norm, when computers just do that, then we seem to think, we've moved the goalposts, that's no longer artificial intelligence because, hey, they're just, they can do it now. So it's tricky to define, and we'll certainly leave out any thoughts about perception and consciousness and thinking. I mean, those are great and interesting if we were on a college campus and taking a philosophy course and so on, but I don't think we have the time or the inclination to debate those things here. And certainly we could envision lots of systems working at a somewhat human level without them having anything like emotions and thoughts and things like that, and that would be okay for much of what we're doing. So I think that just gives us some framing there. And then this idea of machine learning is really a subfield of AI focused on learning, because AI also includes things like robotics and systems that might not be learning, that just do something mechanical and don't necessarily need to change their behavior. And I think the important thing here, the reason we're actually here, is there's really this trifecta of three things that has made machine learning explode and data science be popular in the last 10 or so years. And that is, we've got all this data now that we didn't have before, right? So the late 2000s to 2010, we started to really accumulate and be able to store and manipulate lots of data. And that is one of the drivers of this whole explosion of machine learning. The other is, of course, computers have continued to get faster. Historically, I think if you go back to about 1959, that's about 60 years ago, Arthur Samuel, fairly famous, he wrote a program to play checkers. And the reason he wrote checkers and not chess is because we didn't have the computational power in those days to actually do something like chess. But he wrote a program to play checkers, and he wasn't a very good checker player himself, but soon found that the program was beating him. So that's one of very early instances of machine learning 60 years ago, but it was somewhat hampered by we didn't have any data really, and the computers were very slow. And then the third thing that's really kind of driving this explosion of machine learning is over the last 10, 15 years, we've gotten much better algorithms. So as I said, 60 years ago, people were doing machine learning, and even in the 1930s, there were papers and thoughts about getting machines to kind of think or do work like that. And so it isn't a new idea, but these three things together make it so that we're really able to do all this and work together in this room. Otherwise, we'd be talking about and learning something else. But all right, so that kind of gives us some thoughts there. The idea here is that we're going to take some data and feed it into our system. Here it looks like a crazy robot, and then there's some model inside the robot. The model is what we would call perhaps an instantiation of a machine learning algorithm. That is, the algorithm is a way to do some machine learning, and the model is a machine learning algorithm applied to some set of data that we have. Right? Because machine learning is only going to work if we have data, and we can make predictions for the future from the past data. If we don't have any data, we can't expect to be able to make any reasonable predictions. And so then our machine is going to spit out some answers, some predictions. And that's essentially how the idea of machine learning works. You might have this idea, you want to try to look at retinal scans and see if they represent diseased eyeballs or retinas or whatever. I don't know much about that. So maybe you've got two groups, right? You've got some of these retinal scans, the red ones are diseased and the blue ones are healthy. And so what you do is you feed the data that you have into, as I said, various machine learning algorithms. There are various ways to do this. And what they essentially will do is they'll create this model that then will take new retinal scans that have never been seen before by the computer and separate them into groups, right? So some of them have been diseased, some of them are diseased, some of them aren't. And the model will say, okay, all of these here are diseased, and you see it's actually wrong on this one here, right? 3, 6, 8. 8 of the 9 are diseased, but it's wrong on one of them. And then it says that, okay, these here are not diseased, and it's wrong on one of those as well. You're never really going to get 100% correctness with machine learning. That's one of the difficulties, I think, with people who are trying to pivot from, say, an engineering role to a machine learning role. Is in engineering, there's one right answer, right? I mean, there's only one way to build a bridge, I guess, or there's a lot of wrong ways to build a bridge and it'll fall down. So engineers are used to kind of there being a right way, and engineers are used to there being a single answer. 2 + 2 is 4. And if you tell me it's something else, I'm going to argue with you. But in machine learning, you're never going to get 100% correctness. So you can try all sorts of different models or different algorithms and different data sets, and you'll get different results. And a lot of it is a bit of an art as opposed to a science in terms of picking the best one and tweaking the model just right and so on. Okay, I'm going the wrong way. Apologies for that. Okay, and so again, if you're, as I said, one thought is that some of you may be interested in transitioning to data science, or they're doing it as a hobby or really moving it into it as a career. And for that, it's worth understanding that in some sense, it's true you don't have to know math, but it certainly helps. I would say in order to be a successful data scientist, you should at least understand probability and statistics at a very deep level because they are used very heavily. It wouldn't hurt if you knew linear algebra and calculus as well, but you'll probably find that a lot of working data scientists don't use those branches of mathematics very often. But statistics is something that's important to understand. You really cannot be successful in the data science sphere without that. And then, before we jump into some code, here the idea is just to understand the different kinds of questions that you can answer with traditional machine learning. So what we just did with the retinal scans is this kind of thing. It's classification. Does this retinal scan represent a healthy patient, or does this retinal scan represent a diseased patient? It could be cancer and no cancer. Could be male, female, all sorts of things. Could it be, well, those are a couple, those are good examples, but let's, we'll stick with those. But what else? The other thing that we do with machine learning quite a bit is to predict, how much or how many. That's typically called something like a regression. So I've got some variable that I know on the x-axis. That could be age. And then I've got some prediction I'm going to make on the y-axis, could be salary. So I could be tasked with, knowing someone's age and nothing else, try to guess their salary. I'm not probably going to do a great job of that, but I do know that salaries tend to go up as people get older and so on. Or, maybe less politically correct, I might have their height and I want to guess their weight, like at a carnival. And, I'm going to use something like this to do that. So that's called a regression. And the idea is that we're giving the output that we're generating is a real valued continuous value as opposed to these discrete buckets. Maybe another one that's a better one would be the home price, the price that a home should sell for. So given some information, some piece of information here, maybe the city that the home is in, I'm going to try to, well, it'd be better if it was a real valued, maybe the square footage. So given the square footage over here, I'm going to try and predict how much should the house sell for. And clearly apps like Zillow are doing things like this, but obviously they're not just relying on one piece of data like the square footage, they're relying on a lot of things like geographical location and so on. But so that's classification is putting into buckets, regression is sort of a real valued continuous output. Then sometimes we'd be interested in anomaly detection. Is this thing different from these other ones? Could be that your activity online, if you're logged into a CRM system like Salesforce or Adobe and so on? Is your behavior somewhat anomalous compared to the other people that have used this system in the past? Can we identify hackers and so on from their behavior? So anomaly detection is another thing. Another thing that's that also fits under this umbrella is reinforcement learning. Kind of what should I do next? You could think of like the Roomba or one of these things that'll vacuum your house. Should it go charge itself? Should it go try to vacuum more? And usually there's some kind of penalty and reward associated with certain actions. And the idea is that you're going to basically reinforce some behavior over time with this penalty and reward, in some ways, kind of like we do with our kids, And so that's another kind of question that could be answered. And finally, clustering or recommender systems, we're pretty familiar with these. This is sort of like Netflix, right? The way Netflix recommends things for you to watch is essentially by finding people who are like you and then looking at what they watch. It's a little more complicated than that, but the idea is we put you in a group essentially with somebody who is like you, maybe age, maybe geographic location, all that kind of thing, and then from there we can recommend things to watch. All right, great. So now we can actually jump in and get our hands dirty a bit. This particular, I'm going to see if I can put this in here for people to see. So I don't know if everybody can see that link I just put in there, but if you click on that link, you can get to the materials that we're going to use for the workshop today. And if you don't already have a Microsoft account, go to account.microsoft.com and you can sign up for free very rapidly to do that. You're going to, with your email address and so on, and that'll allow you to log in. Okay, so I'm hoping that people were able to see that. I'm going to switch tabs here to show you that you'll actually need a second link here. But once you've created an account, I'm gonna give you another link that I'm gonna put in there. I'm assuming this is going to everybody. So this next link here is going to take you to what are called Azure Notebooks, and I'll talk about what they are. But it's going to take you to some materials that I have here. Actually, what I would like you to do, yeah. Okay, so if you've created an account and you're at this URL that I'm at, you'll notice there's a clone button, much like you probably are familiar with at GitHub. If you click this clone button, you can take this project that I have here and make your own local copy of it. You're going to need to do that in order to actually do any work with these, because if you take a look at mine, so if you were to click on one of these things, like this #1 joining datasets, if you didn't clone it, it'll just look like text here. You won't have the ability to actually interact with it, which I'm going to do in a moment. Okay, so let's review. The Reactor NY, the bit.ly Reactor NY is the link that will take you to here, I think. So maybe I didn't need to give you this link too. I think it takes you here. Assuming you have a Microsoft account, you should be able to see your login name up here. You can see mine says Dave Wade-Stein. Yours will say whatever you created. And you'll go ahead and clone this project, Machine Learning 1, making your data useful, etc. And then you'll have your own copy of that. And again, this is a little tricky, not being in a classroom with people, not being able to see somebody raise their hand if it's not working and so on, but I'm hoping that this works somewhat flawlessly for you. And once you've been able to clone it, the goal is to then click on this one joining datasets file here, and it will look something like this. Okay, so I don't know, maybe I'll wait a minute, but do we have any way to know, can people say, hey, it worked for me? Does anybody want to say that, just so I can feel like, okay, this is successful? Because I don't want to get ahead of people and have them frustrated. Any working for anybody? Let's see. Well, I'm not sure how to tell, unless you can put it in the chat. Can people do that? Let's see. Okay, nope, it's not that. All right, so let me go back here and let me make sure I can see the Q&A. All right, well, I'm gonna assume that it's working for people. Hopefully it is. As I said, this is a little more, a little easier in person. But the idea here is that there's a couple things to understand. So Microsoft has a product, a free product called Azure Notebooks. Now they are going to be, I think, deprecated as of September of this year. And they give you ways to migrate your work off of there. You can see this migrate your notebooks button. Yeah, it says here it'll be retired on September 29th. But for now we can use it and we can learn a little about it and see what we can do with it. And so the idea behind Azure Notebooks is that we've essentially got Python code wrapped up in something called a Jupyter Notebook. And that's what is open here in this tab that you clicked on once you've cloned the project. And you'll see that Jupyter Notebooks consist of a bunch of cells that you can click on, these rectangles. And inside those cells are essentially one of two things, either some text, which is typically in Markdown format. So you can see there's this little pull down menu here that lets you choose what is in the particular cell, or what's in the cell is code. And you'll notice it's highlighted green when it's code, it's highlighted blue when it's text, although typically we can tell the difference between text and code, but not always. And if you double click on a cell, you can see that this is in fact just Markdown, just like we're used to on GitHub and other places. And the way you can render a cell is by clicking this run button up here in the toolbar. So if you double click and you say, oh, I don't want to look at the Markdown source, I want to actually render this so that I see formatted text, I can just click the run button and that will happen. The other option, and there's a keyboard shortcut, is you can hit Shift Return to render the text. You'll also use the same run button or the keyboard shortcut to run Python code, which we'll do in a moment. Okay, so these notebooks consist of text and code and sometimes images and animations and so on. And so you see they're somewhat like a real world notebook, but obviously very dynamic and things that you can edit and change, and really a great way to share information. They're used very heavily in the data science and machine learning community, but they're also used in places like econometrics and statistical analysis, anywhere where people are doing work with numbers and Python. There you can also use other programming languages in here like R and so on. And anywhere where people are doing this kind of work and they want to share it with other people, and these things are often checked into GitHub and shared that way. Or other ways of sharing information. The notebooks themselves are just JSON, so they're text, and so it's easy to be put these in GitHub and share them, and even attach them as a attachment if it's a small notebook and things like that. Okay, so the goal is basically to have this living, breathing document that we can work with and edit, as opposed to the old school, PDFs and things like that, which were not very dynamic. Okay. All right, so let's get into the material, and I'll have you follow along with me. So, you're going to be scrolling down, and then also we'll be looking at some code here. Now, again, because of the short nature here and the various backgrounds of people, we're obviously not going to go deep into it. It does say a deeper dive into joining and cleaning data sets. As I said, this was originally extracted from a longer day-long workshop and so on. And so you will forgive me if it doesn't seem as deep as you might have thought. But all right, so let's talk about the basics here. As I mentioned, data scientists spend a lot of time just playing with their data, manipulating their data. They spend about 80% of their time and effort is devoted to preparing data in a particular project. And for some people, that's actually the fun part. For other people, the fun part is actually doing the machine learning and trying to get the output. But unfortunately, you can't be successful. You won't be successful in machine learning unless you spend this time ahead of time doing the data cleansing and data manipulation and so on. And we'll look at some of that here. But the basic idea is that real world data is dirty. It's missing data. It's full of junk. People fill out forms incorrectly and so on. So that those data sets never look good, and they can't be used for analysis until they're cleaned up. And also, most real world data is split amongst multiple data sets. So that means that we often have to clean and then join them together after the fact. And so that's one of the things we're going to be talking about today is joining and cleaning data sets. So if you want to be successful in data science, then mastering these skills is essential. We're going to use something called Pandas. It's a Python library for data handling and data manipulation. Pandas really just is short for panel data. You think of panel as being like a Microsoft Excel spreadsheet. And so it was created around 2010, I think. I'd have to go look for sure, but by a fellow named Wes McKinney, who was working on Wall Street and wanted to do analysis of data and found that Python really didn't have the chops to do it. Python is a great multi-purpose programming language, but it's terrible when it comes to numerics and terrible for this kind of manipulation. But thankfully, people have created tools that sit on top of Python. They're essentially Python libraries, or we call them packages, in this case, that can be used with Python to do the work for us. So, the other reason we're in this room, besides the trifecta that I mentioned earlier, is because of Wes McKinney. If he hadn't created Pandas, we likely would not be here and probably not using Python for this kind of work. So in order to make this a little more like real world scenarios, we're going to use data taken from the U.S. Department of Agriculture. It's something called the National Nutrient Database for Standard Reference. So it lists a whole bunch of foods, and then it identifies, or it contains the nutrients, how much fat and calories and all that business. All right. So to get started, we're going to use Pandas, and this cell right here asks us, or tells Jupyter, that we want to import the Pandas package. And by convention, we rename it PD, so that in our code later, when we want to refer to it, instead of having to type out Pandas, we just type out PD. Now, this convention really just came from Wes McKinney, because when he created Pandas and created a bunch of documentation and examples for us to follow, he would type import Pandas as PD, and so the world now just follows suit. So you need to run this cell either by clicking the run button or hitting shift return. And you'll briefly see an asterisk over here that means that the Python is thinking about it, and then when that goes away, it means it's done. By the way, in case it's unclear what is going on here, we simply have a nice web-based GUI that's sitting on top of Python that's running either on our machine. In this case, it's running up on a machine in the Microsoft Azure cloud, but you can run Python and, of course, Jupyter on your own machine. And then what you would have is you'd be running a web browser on your own machine, and you'd be talking to a Python on your own machine. But the idea is this nice web-based GUI is sending information to the Pandas, to Python under the hood, and the Python under the hood is doing the work and then sending back the results. So in this case, there's nothing to see. We've imported this package. And so it might be helpful to start out with, how do you get help? How do you figure out what's happening, especially if this is the first time you've experienced some of this stuff? So Jupyter gives you some ways to figure out what's inside a package. So if we want to know what's inside the Pandas package, we can do that by just typing. So in this next cell, we've kind of done the exercise here. Again, because we're doing this as a fairly brief, in the scheme of things, 90 minutes plus questions, I think is how we're going to do it. Because we're doing it in a fairly brief time period, we're not doing as many, say, exercises that you do on your own. Instead, we're going to kind of do them together here. But if you put your cursor right here after the period and hit the tab key, you should notice that Jupyter gives you potential things that can come after the PD period. essentially it's telling us what are the functions and data, variables that are inside the Pandas package. And so you can pick a particular item, maybe pd.dataframe, and you can further explore that. So if we hit a tab here, again, oops, and let's say data frame, because data frame is something we're going to be using. You could put a period after that and then hit a tab and see, okay, their data frames let you do all this stuff. Because as we mentioned up here, Pandas is huge. There's a lot of stuff in here, and even working data scientists don't understand all of the functions and everything that are available. Obviously, they're going to understand the ones that they use regularly, but the idea is we want to just see if there's some nice ways where we can kind of get some help here. So if we just want to see what's inside something, this dot and the tab can be helpful, and we can kind of say, oh yeah, that's right, what I really need was concat. So sometimes you just use it to jog your memory. But in addition to that tab completion feature, you can also access help with the question mark. So in this next cell, what we've done here, well, let me just set it up. If you don't understand how a function works, what are the, what's sort of the docs for it? Obviously, a good way to help yourself understand that would be to go to the docs. So Pandas gives you, or sorry, Jupyter gives you a way to do that by putting a question mark after something. So we've imported Pandas as PD. If we put a question mark and then run this cell, then we click run, you'll see that a brand new window comes up, resizable, that gives you the documentation for the specific thing you asked for. Now, Pandas is huge. We're seeing the whole documentation for Pandas here. That might not be what we want. We could exit out here and say, well, just tell me about Pandas data frames. So again, I could put a question mark after that, click the run or shift return, and now I've got the docs for the pd.dataframe function, and I can see all the different parameters. I can even see some examples and so on. Obviously, we could just open up another window and Google it, and sometimes that's better. But if we just want a real quick drill down, hey, tell me what this columns parameter does. Okay, got it. And then we can even leave this on the screen just by resizing it and refer back to it. So that's another option. And it also turns out that there's a Python feature for helping you that does not require Jupyter at all. And so what I'm going to do here, and I invite you to do the same thing, is I'm going to I'm going to go to the insert menu and insert a cell below. So I have an extra cell now that was added in the notebook. And I'm going to use Python's built-in help function. So Python has a function called help. And if you pass it the name of a function, it will tell you how to give you the details on that one. So for example, in this pd.dataframe, I just hit a tab there and I expanded it, and now I can get essentially the same output. It should be the same as this, just in a cell as output from Python. So this is just pure Python underneath the hood, giving me the docs. I might prefer to do it that way if that's the way I think, or I might remember to use this question mark and I got it this way and so on. But in general, it's worth understanding that, for almost anything, there are multiple ways to do it, right? And so pick the one that makes the most sense to you. And I could delete this cell here, or delete cells. If I say that I don't want that here, I'm just going to move this down. And let's talk a little bit about Jupyter Notebooks, because for some of you, this may be the first time that you've experienced them again. I know that the Reactor, the description of today's Reactor said something like you should know Python and you should know Pandas. That's great, but we certainly don't exclude anybody from signing up. And what I found from teaching these in person is that people rarely read those, and that's okay. So I'm really having to take the approach here that that not everybody has this background. It's just, otherwise it's going to be very difficult to kind of know. It looks like somebody asked the question. So what I'll do is I'm trying to keep an eye on the Q&A, and if the Q&A, the question I see is relevant at the moment, if it's something about something we're talking about, I'll try to jump in and answer it. Otherwise, I'll try to we'll reserve the last 30 minutes for questions and things. We'll do it there. Now, this particular question somebody asked is, why are the notebooks being deprecated? I honestly don't know that. I don't work directly for Microsoft. As I mentioned at the beginning of the talk today, I work for Develop Intelligence. We're a training company, and we've partnered with Microsoft to do these reactors around the world. So as I said, I've been in Tel Aviv, and on Thursday I'll be doing a virtual one for the West Coast, and then in August I'll be doing one for I think it's Introduction of Programming or Introduction of Python and so on. So I can't, unfortunately, I can't answer that, but maybe some of the Microsoft folks who are on the call could jump on and explain it. If I had to guess, I would say they're being deprecated perhaps just because they have not been used that much. And so it wouldn't make sense for Microsoft to continue to offer them. But okay, so back to this. As I said, the course makes extensive use of Jupyter Notebooks, and they're hosted on Microsoft Azure, which will be deprecated. The goal here is just to let you experiment with things. So you can log in and play around and not have to do this, and have the computational power up in the cloud to do this. But these things can also be done on your machine as well. We talked about how Jupyter Notebooks are divided up into cells, great, and how they typically contain Markdown, like here, or code. But let's take a real brief tour, maybe spend 5 minutes here so that you understand how to get around. Now, as I said, you obviously can just simply scroll from one cell to another. The insert menu that you saw me use earlier allows you to add cells. If you say, oh, gee, I don't want this one here, I can use this arrow from the toolbar to move it up here and down and so on. So it really is a nice interface that lets you essentially kind of capture all your thoughts, not just code, but also notes in the process of a project. If you're doing a data science type project, you're going to have some thoughts and notes, and let me try this and see if it works. And you're going to want to usually keep all that so other people who are looking at your project have an understanding of your thought process, so they don't repeat work, for example. And the other thing that's very useful with Jupyter Notebooks is, typically if you have a data set in your organization and that data needs to be transformed and manipulated in order to do your data science, your machine learning work on it, what the conventional wisdom is that you make a notebook that opens up that data set as it is, with all its warts and problems, and then you write some code to manipulate it and get it in the place you want it to be to do your machine learning. And that way people can see your process. You don't want to say, well, we got this data set here, and so I'm going to edit that, fix all the problems, and then put it back and not have the original data set anymore, lose the provenance of it, for example. So you'll often see data science projects, read in a dirty old CSV file that's missing stuff and so on. And then in the context of the notebook, they make changes, some of which we'll do below, or manipulations, and you can see how they got there. But they left the original data alone. All right, so there's this, ability to insert, move cells around. A lot of this is going to seem familiar with any apps that we're used to, but you can do things like download the notebooks. The notebooks are by default in this. Here you'll see that the extension is IPyNB. If you're wondering what that comes from, this project that is now called Jupyter was originally called IPython, or Interactive Python. And so this is an IPython notebook. And the reason that the name changed is that throughout the evolution of IPython, the folks who were building it realized, hey, we don't really have to use Python under the hood. We could use other programming languages. This web front end that's pretty cool and allows us to create these notebooks, that could sit on top of all sorts of other languages. And that's what they did. And at that point, then it doesn't make sense to call it IPython if you're going to use Golang with it, or the R programming language and so on. So I changed the name. And you can actually just go to jupyter.org to see the home page of the project. And the name Jupyter gives us a clue as to what they were thinking. So the name Jupyter actually comes from Julia, which is a programming language. Python, Pyt, obviously another programming language, and R. Those are three programming languages that are used very commonly in Jupyter notebooks. And then of course the E is just to make it sound good, right? Because otherwise it'd be Jupyter, right? So the name changed, but the extension didn't. And I was in the process of just showing you that you can download a notebook and convert it to these other forms. I wouldn't recommend it though, because in its natural form as a Jupyter notebook, it is as general as it could be. If you convert it to HTML or you convert it to PDF or Markdown, now you've lost the ability to do all this cool stuff like run the code in line and so on. So I wouldn't recommend doing that, but if you need to do it, you can. And so you can edit, copy, paste cells, move them around, split a cell in two, merge a cell together, all the kinds of manipulations you could imagine you can do. So it's worth, slowly learning the different things you can do. They also have keyboard shortcuts, which I think you can access by hitting an H, and you can see the keyboard shortcuts. So you can get really into this, and some people are very, very adept at moving around and using all these different tricks. The only thing I'm going to point out here that I think I want to be sure people understand is, so under the hood, we're running Python, and that's really called the kernel. And I doubt anything we do is going to cause this problem, but in some experimentation that you do, it's possible that you will get the underlying kernel, the underlying Python hung up. It'll be stuck, and it'll seem like you're, typing code in here and trying to get it to run, and it's not doing anything. And in that case, you might want to go up to the kernel menu and possibly do an interrupt or restart the underlying Python. And that's just a way that you can gain control over a kernel that is, perhaps not responding. So that's worth understanding. That's about all I think we need to talk about here to get us to be able to move forward. But there's a note here. The idea is that we really want to go through these cells one at a time and run them. But in this cell menu, you'll notice there is a run all and a run all above. If you've got a long notebook that one of your coworkers or somebody has given you, and you're kind of 90% of the way through, and you just want to start looking at things at that point, you might say, well, let's just run everything above and not worry about it, get all of that Python run, and then I'll start looking at the remaining cells. And the note here is just saying, don't do that here. We really want to go one cell at a time and understand this stuff. It does say that some cells have errors, and so then that will stop the running. I don't think that's actually true at this point with this modified one, but let's just do it, one at a time. All right, so great. We understand that we've got Jupyter Notebooks. It's a great tool. We understand that under the hood we've got Python and we're using Pandas. And so now what we want to do is learn how to load in data, because one of the big wins of Pandas is that it can pull data from just about any data source you want. It can pull data from a CSV file, of course. It can pull data from an Excel spreadsheet. It can pull data from any of hundreds of different databases and so on. So the idea would be, however your data is stored in your organization, you could write a Jupyter notebook, you could write some code that would pull it out of a database or pull it out of AWS or something, Snowflake or whatever, and bring it in to your notebook, because Pandas has the ability to do that. We're going to do a very straightforward loading of data using a Pandas function called read_CSV. And before we do that, we want to understand this idea of a data frame. And a data frame is essentially a 2D data structure, much like an Excel spreadsheet. In fact, the goal of Pandas is to let you manipulate data in very much the same way that people have historically done with Excel. Right? I mean, Excel does some cool stuff, but it really has some limitations when it comes to writing your own code and so on. It's difficult to do. So here we're going to marry Pandas with Python, and underneath the hood, Python is as I said, a general purpose programming language that lets us do a lot of cool manipulation and stuff. And then Pandas is specific to data manipulation, and together we can do exactly what we want. So we're going to do a read_CSV, and we're going to read in from this data folder, because if you actually go back and look at the project you'll notice that in addition to there being 3 notebooks here, we're only going to get to the first one today, but in addition to there being 3 notebooks, there's a data folder. And if we click on that, if we click on the data folder, we'll see there's some CSV files inside there. And the one that we're going to read in is this USDA National Nutrition Database. And so you could click on it and just, see what it is, convince yourself that it makes some sense. There's obviously some foods here, butter with salt, etc., all sorts of various cheeses. And then there's these different columns that represent various nutritional pieces of information, how much calcium do they have and so on, right? So it's a regular old CSV file already in the project for us. And so we're going to read it in with this command here. So let's click the run button. And if all goes well, it should work. Now you'll notice if you read this carefully, it'll say, it might seem strange that we immediately encounter an error. Well, we didn't encounter an error. But I think in the first iteration of this class, as I said, they're in the process of changing them up somewhat, and not everything has been completely migrated. So whatever they did in the first iteration, it was creating an error, and they explained to us why, that we had to tell Pandas what the encoding of the data is. But it turns out it works fine. But you can also see that read CSV takes many parameters, one of which is the encoding, and so they solved this problem, which isn't a problem for us, by saying let's set the encoding. But one thing you might do is just create a new cell and either use help or our question mark, and you might say, all right, what is this actually? I thought that would work for us. Well, we can always do help on it. I'm more of a help person, but if you look at this function, you'll see that there are lots and lots of things that it can do. And of course, we aren't interested in drilling down deep in terms of what it can do, but the idea is that we can read from a CSV file. There's also read from an Excel, as I said, read from various database types and so on. But you can see there's lots and lots of different parameters. This is supposed to be a CSV file, and so the separator, for example, SCP, is set by default to a comma. That would make sense in a comma separated file. But if you had a tab separated file, a TSV file, you could set the separator to a tab here, and then Pandas would properly parse it and so on. So at each step, when you're learning some of these commands, it might be helpful to just take a brief look, not try to read too deeply, because there's obviously way too much to understand. And oftentimes looking at the manual is much better when you need a specific thing and you have to understand it right then. But occasionally it can be good just to kind of get an idea of the scope of a particular tool. All right, so we've read in this data set. We can run the head function on it to see the first 5 rows. As you might imagine, there's also a tail function. So head will show us the first 5, and if 5 isn't enough, we can put a parameter in there and tell it how much we want to look at. The nice thing about Pandas, one of the many nice things about Pandas is it tries to keep you from doing things that aren't very smart, let's say. So suppose we wanted to look at the entire data set. Typically, our data sets are so big that wouldn't make any sense, right? If you have an Excel spreadsheet with tens of thousands or hundreds of thousands of lines in it, rows, you can't look at the whole thing, right? You can scroll around, but you can't see it all together. But if we just ask Pandas, hey, let's see the whole thing, you'll see that it shows us, say, the first 30 rows, and then a ... and then the last 30 rows. So instead of this thing scrolling like crazy off the screen, Pandas just says, well, you don't really want to see the entire thing, so I'm not going to let you see it. But it's customary after you read something in to look, do a head, and let's just do a little sanity check on here. So we've got some columns across the top. They seem like they make sense. Some of them we might not understand. We're not like food scientists, but I think this is short description, and then grams of water and protein and so on. And this is probably the nutritional database number, right? And so each item probably has a distinct value in there. And then this first column is actually just Pandas numbering the columns for us, starting with 0 as we traditionally do in the computer world. So great, this looks like it makes sense. You see, we don't see all the columns here either because there were many. So we see the first and the last, but there are various things you could do. If I add a cell below, I can even ask Pandas. I could just hit a tab here and say, I know there's a columns thing. Show me what the columns are. And actually what I get back is a Python list of the column headers. So I can see that NDB number and short description and so on, but I can see the missing ones here after sugar, tote, wherever that is here. I can't see it right now. Let's see, somewhere in there. It should be in there. There, sugar, tote. Then there's calcium and iron and so on. And we see we don't see those. We're all the way to vitamin K here. So we're kind of missing all of these in the output. But if we just wanted to get a definitive list of the column headers, we could do that. And so on. I mean, there's an endless supply of things we can do here, and I'm just alerting you to a few of them. All right, so let's think about exploring and cleaning up data, which is kind of our overarching goal here. And I think this is probably worth noting. There's a saying that the difference between data science and academia and the real world is that academia likes to do complex analysis, on clean data sets. Because in academia, their data sets are always nice and clean. There are no problems, nothing's missing, everything looks good. So they can do all sorts of complex data analysis. But in the real world, you often end up doing much simpler analysis on messier data sets because it takes so long to get the data set in a form that's actually analyzable that you don't have to end up doing too much. But when you encounter difficulties, troubleshooting those difficulties is really a large part of successful data science. So a lot of data scientists will have a lot of skill and experience troubleshooting issues that the rest of us don't really understand or have a window into. If you are someone who's planning to move into this or hoping to move into this as a career, and I certainly encourage it if it interests you. These are the kind of things that you want to be good at, you want to be successful at. I teach a lot of programming to people who don't know how to program. I also teach programming to people who do know how to program. And I think one of the things that makes someone a very successful programmer is, I would say, tenacity, right? The ability to stick with it and keep going when things are not working. And I think there's a big overlap with data science. You try to read in a data set, it doesn't work. You got to look at it, you got to pay attention, try different things. And so tenacity, I think, is important. Problem solving ability, that kind of thing, I think is super important. And then there's a lot of things that don't overlap. Like I said, I mean, to be a successful programmer, you do not need to know math hardly at all. But to be a successful data scientist, as I said, you need to definitely understand data science, statistics, probability and statistics. And while there is some overlap, there's a lot of non-overlap. But all right, so we had our data frame. We saw we could do head or head 10 here and take a look at it. We can also use the info function or method here, if you want to call it that, that's fine. And if we do df.info on this data frame, we can see some interesting things. I mean, for one thing, we can tell how many columns we have. Okay, we got 53 columns. We can see that there are 8,790 entries that are numbered 0 to 8789. Great. And then we get some analysis of the individual columns. And what Pandas is telling us is how many of the items in each of these columns are non-null, meaning how many are not missing, because a lot of times things are missing. So what we'll notice is that for the NDB number, the nutrient database number, of course, they're all there because every one of these nutrients has some number assigned to it. But I don't know, we don't have information about ash in some of these things, or maybe it doesn't make sense. I don't know, maybe sugar and so on. So a lot of these things are missing, either missing information or they don't apply. And we would have to understand that. If we're going to try and do a successful data science and machine learning activity, we would want to know, okay, are these things missing? Or when they're missing, does it mean that thing doesn't have any? One way to look at it might be to look at this column and see, are there zeros in there or what's in there, right? So understanding your data is tricky, and it requires a lot of thought. It's not something that one can do at a glance, and that's why the machine learning part really has to wait until we have a better understanding of our data. It'll also tell us that 48 of these columns essentially have floating point numbers in them. 2 of them have ints. Let's see what we could see there. Okay, so kilocalories or calories are integer quantities, not floating quantities. And this the database number, the unique number for each one is also an integer. Everything else is a float, or it's what's called an object. And what we don't know yet is that Pandas is actually built upon a very famous package in Python called NumPy for numerical Python. And NumPy is really interested in numeric types and so on, because Python isn't, being a dynamically typed programming language. So this is NumPy under the hood saying, hey, these things are ints or floats, and when they're neither of those, when I can't categorize them into ints or floats, I'm just going to call them objects. They are likely strings, but it could be a mix of strings and numbers. Something like the short description seems like that's all going to be strings. But if our data set was messed up so that we had a column that had floating point values, but then also some strings mixed in there, and believe me, that happens all the time, then NumPy under the hood, and therefore Pandas, is just going to tag this column as an object because it can't deal with it numerically, because not all the values are numeric. So it's important to understand that to tell us how much memory we're using, right? There's a lot of stuff in here, some of which we probably don't care about. All right, but our point is almost all of the columns have a lot of null values. And this idea of values that might be missing, they're not really an issue for us now, but they'll be challenging in future sections. Like, I mean, in real life, missing data is typically a problem. When you're an academic teaching a class and so on, as I said, you can just have a data set that's perfect and not have to think about it. But in real life, you have data that's missing. The question is, what do you do with it? Like, if I'm trying to come up with some conclusion about particular foods, and I'm actually missing some of these data, it's going to be hard to come up with a reasonable conclusion. Or if I have a bunch of data on my customers, and 30% of them are missing their age, and I want to be able to make some conclusion like, do older people watch different things on Netflix than younger people? I'm going to be in trouble because I don't have the age data. So it's really an art to figure out what you do with missing data. And every problem is different. So you can do things like average the other data. So what I could do is say, okay, for 30% of my data points, I'm missing the age. Maybe there's other things that I know about these people that will give me a better window into their age. I could maybe look at their sex. And so now I could take the average age for women, and anyone that's missing, I'll just put that in there. And then the average age for men, and I'll put that in there. Or I could look at their titles, right? If they're a Mr., I would assume they're probably older than if they're just maybe a male without a Mr., and so on. I mean, there's all sorts of things I could do, and there's no one right answer. So that's another thing that people struggle with when they come from the engineering computer science world, is they want an answer. They want a one-size-fits-all answer, which often works in the other fields, but doesn't work here. There's an old saying, and to the extent that machine learning is old, there's an old saying in the machine learning community that there's no such thing as a free lunch. So what they mean specifically is that there's no one algorithm for doing machine learning that is going to give you the best results for every data set. So you have to try a whole bunch of different ones. Whereas, as I said, I think there's probably only 1 or 2 algorithms for how to build a bridge. I don't know, right? But if you're building a suspension bridge over an ocean or something, there's probably only a couple ways you can do that right, and a bunch of ways you could do it wrong. But in machine learning, that's not the case. So it's just, you really, I think if you do want to make the move to machine learning, data science, that kind of thing, it would help if you have, a somewhat open mind in terms of being able to let go of the engineering mindset. And if nothing else, even if you intend on remaining firmly in engineering or computer science, being exposed to data science and machine learning, where it's a different way of thinking, that really, I think, can make you a better engineer, even when you go back to your field where there is only one right answer. All right, so yeah, duplicate or missing data can be a problem. Also, duplicated data can be a problem. You'd be surprised how much that turns up. So we can actually query Pandas and say, hey, do we have any duplicated data? So there's a duplicated function or method here. And what we're going to do is we're going to rely on some knowledge we have about the data set. Well, these NBD numbers here, or NDB, excuse me, they seem to be, counting upwards from 1001, and therefore we wouldn't expect there to be any duplicates in here. If there was another 1007 somewhere in here, it would have to be camembert cheese or something's really messed up. But maybe the rows got duplicated somehow. So we're going to check for duplicated by using that column, specifically the NDB number as an index. And then we're going to sum it up. Well, let's try that. And I kind of made this note to make sure we go through this here. All right, so the 0 tells us there are in fact no duplicates, but the question is, how did we get that? And what exactly does summing it up mean? So if we put a # here and comment out, so we should know that the # is a comment in Python. If we comment out this call to the sum function, we're now just calling the duplicated function on that column. And when we do that, let's see what we get here. And of course, if we were all in a classroom together, I could ask you, what do you think this is, and so on, and people could ponder it and muse it and so on and yell it out. But unfortunately, we can't do that. So I'm just going to tell you that the duplicated function simply emits what's called a series, a one-dimensional Panda series, and you can see that it starts at 0 and goes to 87, 89. That's one for every row in the data frame. And this Boolean here, which is going to be either false or true, tells me whether this row is a duplication of some other row, not just the previous row. So it's telling me, does this row 0, does it exist somewhere else in the database, or sorry, in the data frame? Because it's only going to go up. So of course this one can't be duplicated, but if we had this 1001 line twice here, when we got to this one, which was the second instance of it, we would get a true. So what we're going to be looking for is any trues here. And we can exploit the fact that under the hood, these things are, when I say these things, I mean a Boolean is stored as a 0 for false and a 1 for true. So these are really just a whole bunch of zeros here, or possibly ones. We can just sum them up. And if we get a non-zero value, it indicates that there is a duplication. And if we don't, then there isn't. So great. So it makes sense that there's no duplicate entries given what we know that this comes from a government database. But as I said, in real life, there often is. So let's make some duplicated data just so we can check and see. This little typo here, there's an extra one of those. Okay. So we can use this append method here. What we're going to do is we're going to deliberately make some duplicated data just to try this out and understand it better. So we're going to say, let's make df be the original df, but we're going to append itself to it. So we're going to take df and append it to the end, and the ignore index true just says to let the numbers keep increasing. So don't try to put the same index numbers like these here in the second part that we append to it. We want them to continue counting up so that they're distinct. But you could say false if that's what you wanted. So if you do that, you get no output, but we've created a new data frame here. And you know what we're doing next is let's take a look at the data and see if we can find duplicates. Well, it seems like we could just do this duplicated again, and in fact, it wouldn't be a bad idea. So the truth is we can go back, that we've got one Python session running under the hood here, and it continues to store all of this information. So if we go back up here and try to run duplicated on it again, we're running it on this new data frame here. So if you do that, I mean, to me, that's the simplest thing is, yeah, we just added the whole data frame onto the end. And so we see that, okay, as soon as Pandas gets to that 8790th line, the first one of the duplicate, every line after that is going to be duplicated. And in fact, if you did this, you could see, that all these ones at the end are trues, right? And of course, Pandas doesn't show it all to us, but because we've appended the whole thing onto the end, no big surprise. But we'll also show you another way that you can do that. Pandas has a function pivot table that allows you to create a pivot table, which is basically just another way to look at the data. If we want to be able to look at the data for some specific sub feature of it. So we're going to make a pivot table of the database numbers, and we're going to put that table into dupes here, DUPS, and print it out. And so all we're doing here is we're really just, in a sense, extracting this column. And in the process of making this pivot table, which is not really giving us any useful information because we're just focusing on one column, what we can see is that each of these NDB numbers actually appears multiple times in the data set, which is something we already know, but we're looking at it in a slightly different way. But there's even more ways that we could do it. So what we might do is say, okay, this column here, or any one of these columns, we might want to know what are all the particular values that appear in that particular column. It might be useful if the column had something like male, female in it, or various categorical values. We want to make sure that there isn't anything bogus in there, right? If there's a sex column and it has male and female, we might want to know, is there anything else in there? Are there any rows for which that column has something other than male or female in there? But we can use that function, it's called value counts, to also look at these NDB numbers. So I'm going to suggest what we do is do a df, and then what we're going to do is we're going to focus on the NDB column. We can do that with a dot right here, NDB no. So now I'm drilled down and just looking at that column, not the whole data frame. And then I'm going to call the value counts function and see what that does. What it's essentially going to do is it's going to count up everything, all instances of all the values in there, and tell me what they are. And not surprisingly, what we're going to get is a bunch of twos. So in other words, it's telling me that, okay, there are two lines that have 2047 in the NDB column, and two lines that have 19148 in the NDB column. Not any real new information, but another way of looking at it. And if you want to look at perhaps a more interesting way of looking at that, let's go to maybe kilocalories, right? Let's see if there are any foods that have the same number of kilocalories as other foods. We could do that real quickly by just changing this from NDB here to, is it kcal? What was it again? Energy kcal. Should have copied it from right over here. Energ underscore kcal, right? So what I'm going to do is I'm going to say to Pandas, hey, let's look at that column and then give me the value counts. It's kind of a weird way of doing it, but let's think about what this will do. This will find all the different values in that column. So it'll find 717, 718, 876, and it will tell you how many times they appear. As I said, for things like male, female, that would be useful, right? How many males are in the data set and how many females are in the data set. For calories, not so much, but it'll be sorted by most common to least common. So we'll actually find out, yeah, there are 884 calories appears 156 times in the data set. So we should expect to see 156 instances of 884 in here. So the most common caloric value of the data in here, I don't know why you'd want to know that, but if you want it, is 884. There also are two foods that have a calorie value of 419. Of course, remember, everything's duplicated, so really it means there's one, right? Because we just duplicated the whole thing. But that means that in the original data set, there's only one food that has exactly 419 calories, etc. Okay, so the value counts function can actually be helpful in things like that as well. In this case, it wasn't the best example, but it's always, I think, helpful to understand different ways to see the same result, because then you can try it out. And if you don't get the same result, then it means either something's wrong with the data or you're not understanding how to do it, and so on. So this exercise, really the answer is here. Let's just understand it, because again, in the interest of time, we'll go longer than the appointed 90 minutes because there's more to cover. And as I said, if there are questions, I'll start answering questions. Okay, actually I missed some here. Yeah, somebody's, okay, there are a number of questions here. Fine, so we'll get to those. All right, so sorry for not noticing that. I thought they would scroll automatically, but it doesn't seem like it's scrolling. All right, so here we're asking the question, can we create a pivot table like from an Excel spreadsheet with NDB number and short description? So we're just going to group everything into the numbers and the description. We can again use that pivot table function and say we want both of those columns, NDB number and short description. And when we do that, you'll see that what we've done here is we've grouped everything into their number and the short description, and then we go and for each column, we look at those values. So here are the different water values for these various things. So we can eyeball and say, yeah, what are those things that really have a lot of water? Okay, cottage cheese seems to, fine, good. What are the things that have a lot of, I don't know, percentage of refuse? Maybe that, who knows what that is, right? But you're basically taking the data set and splitting it into subgroups of the columns that you're interested, and then inspecting the individual values so you can compare them against one another, which is, you know, handy. And again, remember that we duplicated that original data set, so you know, we want to get rid of those duplicates if we can. And so what we can do is we can call this drop duplicates function. So that exists inside Pandas and it's very handy. If our data set has duplicates, let's just say, hey, when you see duplicates in this column, let's drop them. And let's set the keep parameter to last, and we'll see what that does. But if we do that, you'll see we're now back to a total of 8,790 entries, okay, which is what we want. But by doing the keep last, we probably shouldn't have done that, but this will just demonstrate, you know, the potential issues that we could encounter. But by doing the keep last, you'll see we actually kept the ones that were numbered from 8790 to 17579. We probably should have kept them numbered from 0 to 8790, but we can fix that. So the data set is now, the data frame is now half of its original size. But as I said, this is our problem now. The numbering is not what we want. We can take a look at the head and we'll see that the numbering now starts at 8790. Of course, the NDB numbers haven't been changed because those are part of the data set, but the index numbers that Pandas is providing, of course, is not what we want. So let's see, trying to remember what we wanted here. I was going to have you do a reset index here. So is this behavior of drop duplicates not updating the index surprising or unexpected? I mean, probably not, because we said keep last. So clearly what we could have done was say keep first, and in this case we would have had the numbers from 0 to 8789, and we would have been good to go. It turns out there's also a reset index function. So if we take a look at that, which seems like it's not giving me my, all right, well, we could do a help on it. Don't know why the question mark is all of a sudden not working, but let's just do a help. So we could do a reset index here, and we could say do it in place. So the interesting thing about these manipulations is most of these manipulations create a brand new data frame from our original data frame, because it's often the case that we want to take our original data, manipulate it in some way, but we don't want to lose it. We want it to be in a separate data frame. But many of these operations have an in-place parameter that lets us do an in-place operation. So we could try a df.reset index in place equals true. I just hit a tab there as well. So in addition to tab completing, working on function names and variables and so on, it also will work on the parameters for the function. So you don't have to type the whole thing here. And so if we do that and do a df.head, you'll see that we are now indexed from 0 onward, but the problem is that the old index, the previous index that we had, was retained by Pandas as a column. Now we can drop that column, but we can also notice, if we go back and do our help reset index, that we could have, sorry, that'll be a df.reset index, that unsurprisingly, there is a parameter we could have set to drop, do not insert the index into the data frame columns. This resets the index to the default integer index. So if we'd said drop equals true here, we can't do it now because it's referring to this, not this. But if we had said instead in place equals true and drop equals true, this column would not be retained and the numbering would be the way we want it to be. Okay. Again, there's a lot to this, so we're just kind of drilling down and seeing a few things. But I think the takeaway for us is if you've got duplicate data, if you've got missing data, in Pandas, they're typically represented as nans, which is not a number. But all of these things can complicate or completely derail your analysis. So learning how to identify them and remove them is really another one of these large parts of being successful. Okay. So what I'm going to do, let's see if we can just do a drop. We could all do this. Df equals, or we could do a df.drop. I think, let's go look at the, I want to do a drop. We could do an in-place true, and we're also going to do a, let's see, labels. So I want to do a drop of, I may have forgotten the syntax, we'll see. We definitely want an in place equals true. I mean, we don't have to do it that way, but I'm going to do in place. And the other thing about, the thing about drop in Pandas that's kind of weird is you have to tell it whether you're dropping rows or columns, essentially this axis value here. I want to drop a column. I want to drop this index column here. So that would be axis 1. If I were dropping rows, it would be axis 0. So I'm going to say axis equals 1, but I want to drop, and I forget, I think I can just give it a list of column names. Let's try it. Index, like so. I think that's right. So I want to drop this column, and I have to say axis 1. If I don't, it'll complain, even though it should be pretty obvious to Pandas what index here is. Let's see if I got that right. Didn't give me an error, so let's insert another cell below and do a head and see if that column was removed for us. Yeah, it was. Okay. So of course, if we had done this right the first time, if we did a reset index here and then said drop equals true, we wouldn't have had to do this additional drop. But it's helpful to understand this command as well, because it's almost always the case that you're going to want to be able to drop something from your data. Okay. All right. I mean, because a lot of, if you think about it, you know, one point that is worth mentioning here, these numbers here, you got a data set of patients, you know, there's no names in there for anonymity, for, you know, to keep them from being in the data, but there's usually some number here that refers to the patient. You invariably are going to want to drop that number, because when it comes time to actually trying to do some machine learning and try and figure out, okay, does that patient have cancer or not? You don't want their patient number to go into the algorithm and have that be part of the prediction. Because at best, numbers like this will provide no predictive value, but at worst, they will actually provide what's called leakage data. So it may be that the data set you got has all the people with cancer at the beginning, first 50, and then the people who don't have cancer at the end, maybe the last 550. And so now when it comes time to do machine learning, your machine learning model, as it were, is going to say, well, low patient numbers are predictive of cancer. And in fact, that's not going to be something that's useful to you. So anyway, okay, so great. All right, let's split up the data frame, because one of the things we want to try to do here is do some combining. So what we're going to do here is we're going to split up a data frame. Normally, we would just be taking disparate data frames from different places and trying to add them together. But here, what we're going to do is split it up so that we can learn how to join them back together. So let's look at this command here. What we're going to do is we're going to take the first, let's add a space after there. We don't really need it there. But we're going to take the first 35 columns. The first part before the comma is the rows. In this exercise, which I'll just dispense with, we're asking, hey, why do we just have this column here, or sorry, the colon here? The colon here represents all of the columns, sorry, all of the rows. It's as if we had a 0 up to whatever the last number is here, 87, what is it, 80, whatever it was, 8790, right? So in Python, what this is this is a slice. Excuse me, went a little too far here. And so it's really as if we had a slice that goes from the beginning to the end. So in Python, when we don't specify the number before the colon and specify the number after, it means start at 0 and go all the way to the length of this thing, i.e. the number of rows. So this is all rows, but only the columns that start at 0. So there's an implicit 0 there. We normally do not put it there. Columns starting at 0 and going up to, but not including 35. So the first 35 columns numbered 0 to 34. And if we do that, if we pull that out of df, we can use this shape attribute to check the size of this df1 thing. Indeed, it's 8,790 columns, and it is, rows, excuse me, 8,790 rows and 35 columns. Remember that originally we had something like 59 columns or what have you, or 54, I can't remember what it was. Okay, so we've taken a chunk of this out, and df itself is unchanged, but we've put that chunk in df1. And great. And we'll do the same thing with another df2. So df2 is going to be df.iloc. Oh, and I didn't explain what iloc is, by the way. In Pandas, there's multiple ways in which you can index a data frame. iloc just stands for integer location. If we would like to treat this essentially as a matrix with numerical rows and columns, then we would use iloc. It could be that what we want to do is actually refer to, say, a particular column that has string data in it, and we might say, let's go from butter with salt down to cheese, comma, brick. And you can actually index a data frame that way with these string indices as opposed to the integer indices. But we're using the more familiar integers, and that's why we're using iloc. And so in this particular case, df2 that we're creating is going to be the first 2,000 rows. So again, it says if we had a 0 here, but we don't need to specify it. So first 2,000 rows, i.e. 0 up to 1999. And then we want to include the remainder of the columns that we missed because we only went up to 35. We have to do a little trick here because we can't just go from 35 to 53. If we do that, we'll lose this crucial piece of information, which is the NDB number. So what we'd like to do is essentially chop this thing into two pieces, but both of those pieces are going to have this exact same column in it. So we'll know where these remaining columns actually what they refer to. So the trick that we're doing here is saying, okay, let's get the first 2,000 rows. then for the columns, let's get the columns that go from 35 to 53, not inclusive, so really 52 here, but that's going to be the last columns. And we're going to add a 0 to that. So essentially this little trick here, this is something called a list comprehension. I always suggest to people that when they want to try things or understand things like this, pull them out of context and say, okay, what is this thing? Well, this is a list with a single 0 in it. This is a list of numbers that go from 35 to 52. That's just because of the way the range function works in Python. So I should have a new list that starts with 0, then has 35, 36, up to 52. And I do. So what I'm saying now here is let's pull out the first 2,000 rows and these specific columns. The 0th one plus these other columns. That's what we're doing here. So we'll run that code. And let's take a look at df2. So df2 that we just made here, it has the NDB number, but it comes in the middle here, right? It doesn't have the short description and all that stuff because it starts at column 35. And we can get more information about df2. And yes, there are 2,000 rows. They go from 0 to 1999. And we can see there are only those 19 remaining columns, or really the 18 remaining columns plus the NDB. So df1 should also have the NDB. It does. And then it has the first, whatever, 35 columns. And we could do a info on that too, if we wanted to. df1.info. And we see that it's the entire data frame, or it's the entire number of rows, 8790, but only 35 columns. So we kind of cut up the data a little bit here so that we could demonstrate how to do these combining operations. Okay, and then we said that the data, both data frames have their old indices that they've inherited from DF, right? Let's verify that. Or do they not because we fixed them? I think because we fixed them, we don't, right? Yeah, I mean, the indices here start with 0, so I think we're okay. But if we had not fixed those indices that started at 87, 89, and so on, we'd want to do a reset index there. So I don't think we'll have to do that. Yeah, this is the things that I did up above, right? We did the reset index and the drop of index here. So we shouldn't have to do these things, and in fact, it will fail if you try to do this because there is no column called index. So we've already gotten rid of that. So we can skip these 3 cells. And we're going to go ahead and write these data frames out to a CSV file. So we did a read CSV to read in. We're going to take df1 and write it out into our data folder into something called nndb1.csv. Oddly, the person who wrote this code added a sep equals comma. If it's a CSV file, the default separator is a comma, so I could leave that out. It's not going to hurt if I put it in, but I don't need to specify it. And then the encoding just says what character encoding to use, and index false will drop these numbers here because I don't need those, right? The original CSV didn't have any index numbers. It just started with these NDB numbers. So if I do this, I can write it out and I should be able to see it in my folder here. I should be able to go back and wake up my tab here. And if I go back here, I should be able to see I just created this nndb1.csv. And it looks, kind of how we expect. There's no index here, just the NDB numbers. That looks good. And you should do the same thing with df2. Okay, so you could take this and let's change this to, to 2 here, perhaps. Copy paste errors are rampant in data science, machine learning, and of course, just computers in general. So be careful here. But here we're going to take df2, write it out to a CSV. Give it a distinct name from the above, use the same encoding, no index, and we can come back here and just verify that we did what we thought we were doing. Where am I here? Ah, there we go, data. Yep, there we go. Now the NNDB2, which wasn't there before, is there. Okay, so we can write out our data, always a good practice, especially if we're in the middle of something and we haven't quite gotten to our solution yet. We might want to write out things piecemeal to make sure that things, are really progressing the way we expect them to. All right, so here's where we're supposed to be. So let's actually finish this part. Let's join the data frames. The idea here, the goal here is to learn how to actually join or merge them together. So if we look at the first data frame, we'll see it's 8,790 rows by 35 columns. The second data frame, remember we only pulled 2,000 rows out of there, and we've got the 19 columns at the end, right? So we can imagine this in our head. The first one has all the rows, but only 35 columns. 18 of them were chopped off. And then the second data frame has only 2,000 rows of those remaining 19 columns, okay? And so when we want to join them together, we're going to use the merge function inside Pandas. And the most common, the default way typically that you do this is what's called a left join. And now, if you're a SQL person, if you've got experience with SQL, MySQL, or Postgres, or whatever these things, this will probably be clear. But for those that don't, we want to make sure that we understand that a left join is a join that takes all the data from one data frame. Think of it as like the left set in a Venn diagram, and merges it with everything it has in common with some other data frame. So it's an intersection with the right set in a Venn diagram. So if you imagine DF1 and DF2 overlapping in a Venn diagram, we're taking the things that are in common. So we're going to say a left data frame is pd.merge DF1 and DF2. And then we're going to use this how parameter to tell Pandas what kind of merge we want to do. And that's a left merge. And then what we're going to merge on is this column ndb no, which we thankfully kept in both of our data frames, right? So df1 has that column and df2 has that column. So that's going to be the intersection. That's going to be the point at which they intersect in that column. And that drives our merge. Where am I here? Sorry. We skipped that. Yeah, here we go. Sorry about that. Okay, so let's take a look at it after we merge it. And what we notice is that our new data frame, the merged data frame, has 8,790 rows, which makes sense because DF1 had 8,790 rows, and it has 53 columns, which also makes sense because 35 of them are here and 18 of them here. One of them is duplicated. That's why it isn't 35 plus 19, because the NDB number is duplicated. But essentially, we've got now all of the rows and all of the columns, but of course, there's going to be some things missing, right? So the idea here is it may not be what we were expecting, because we could say, hey, wait a minute, there's only 2,000 rows for which we have these 19 columns. What's going to happen for the other 6,790 rows for which we don't have that data? And we could take a look and see. So if we remember, our original data frame was 8,790 by 53 from the data set. And, looked something like this, had all of these columns, some of which aren't being shown here again. And if we look at the left DF head, it looks good, it looks right, because the first 5 rows here, of course, have all of the information from here plus here, and we're good to go. But after 2,000 rows, the 2001st row onward, we expect it to be missing some things. So let's do a tail, and we can see, oh, sorry, that's DF tail. Let's look at the merged data frame, and sure enough, it doesn't have those final columns, because remember, we merged with a data frame for which the final columns only existed for the first 2,000 rows. So up to 2,000, we should have really all of the data, but beyond that, we've got a bunch of missing columns. But Pandas lets us do it. Pandas isn't going to say, hey, you're missing data here. The nans here are Pandas' indication to us that these data are actually missing, but it doesn't disallow us from doing that. Now, we could have done the opposite, or the mirror image operation, a right join. So a right join is the mirror image of a left, and those entries from the left data frame that are common with the right data frame are merged with the right data frame. So we're kind of using the right as the driver here, as opposed to the left. And so I'm asking you to perform a right join. Well, it means we could take what we had before here, and let's make sure we give it the right name. So we're going to call it right df, and we're going to do the same merge here, but maybe what we want to do here is, how right, and that tells Pandas, okay, this is the thing that's going to drive the merge, and we're going to look for anything from here that matches here, and we're still going to use the same column as we did before, because it's really the only one that's in common here. And let's try that and do, take a look at maybe the head when we're done here. Doesn't really look any different here. What are we actually expecting to see here? Is a good question. Remember that the right data frame here, df2, we can remind ourselves it only has 2,000 rows here, and it has those 19 columns, which means that, again, at the end of this, we should expect to see some missing data. Let's try it. So let's insert cell below and do a right df tail just to convince ourselves. And in this case, sorry, one thing I forgot to, that is not right. Let's look at the shape after we do this. I forgot that if we're using the df2, which only has 2,000 rows, let's look at the shape of the resulting merged database. Right df.shape we can use. Well, there's only 2,000 rows in df2, so the merge is going to stop after we hit 2,000 rows of df1, because the data frame on the right, that's the smaller one, is the one that's driving the merge. When we did the left merge, we were using the larger one, and that's why we filled in the missing data with nans. But here, we're just going to take the first 2,000, and at that point, the merge will stop. We won't use any of the additional information in the left data frame. And that helps us understand the difference. I mean, whether we want one or the other depends on how much information we actually want to retain here. So if we're only really interested in those first 2,000, if we don't care about the rest of the rows, then this might in fact be the correct answer. But if we want those other rows, even with missing columns, then we would want to do a left join as opposed to a right join, okay? All right, and another way that you can join data, it looks like we will get to the end, and I'll still, we can do some more questions if we need to, but another way to do it is an inner join. And what that does is it merges the entries that are common to both of these data frames, as we did before, and that has no nan values. So what I'm going to say here is let's make a new data frame, inner df, that merges df1 and df2 with an inner join, again, on that same column. That's the only thing really we have in common between them. And, if we were, again, in a classroom together and so on, and people were all doing this, and I could see the smiles on your faces or the frowns or what have you, I might say, hey, what do you predict the shape's going to be, right? And people would raise their hands and so on. Let's just take a look. And what we'll see again, remember that what we're doing is we're looking for common entries that have no nan values. And since df2 only has 2,000 rows, it's not surprising that we're going to end up with 2,000 here and not more of them, because there's only 2,000 rows that have common entries that with no nan values. Let's take a look at the head and tail of them. So the head looks like what we'd expect. Tail also looks like what we expect. There's some missing data, but that was missing in the original data set. but we don't have any of those rows that come after this where there's a bunch of stuff missing as a result of it not missing columns. Okay, so we essentially just get the first 2,000 rows of that original data frame. In that sense, I don't think this looks any different than the right join in this particular case. Right? I don't think so. And so we did an inner, we did an on left and a right and an inner. We could do an outer. Now an outer is the union as opposed to the intersection, so we're going to get everything. Anything that's in either data frame, and therefore we're going to have some missing values because of the missing values in the original data set. So if what we did is we said, all right, let's take this and let's do an outer join, we should see something different. So first let's change the type of join, and let's also change the name of the variable here. And when we do that, let's immediately look at the shape. Now, before we hit return on this, we could think about it. If this is the union, if this is everything, then we should get the total number of rows, right? DF1 had 86, 90, whatever it was. Some of them will have nans in them. And we also should get the total number of columns, and some of them should have nans in them. So the shape of this should be the shape of the original data set. Oops, it's outer DF, excuse me. That should be okay if we do that merge again. Yep. So now the shape of this is the shape of the original data set. Of course, we've got stuff missing, and we can verify that because we know what this came from. But let's go ahead and look at the head. That should look good. It's like everything's in there. But if we look at the tail, as before, we see the missing data. But because this is an outer join, it encompasses everything. So we're going to pull in those nans. And again, the choice of which of these you want to do really depends on the problem you're trying to solve. You might not care that there's missing data here in these data sets that you've merged together because you might be more focused on perhaps one of these columns that exists for everything. On the other hand, if you wanted to be able to make some conclusion about a column that isn't here, maybe you'd have to do that from the first 2,000 rows. Again, a very contrived example here because we had the original data set. But let's suppose you didn't have that. Let's suppose you had 2,000 rows, 2,000 customers for which you have all the data, and then you have a bunch more customers for which you only have a subset. You know, they didn't fill it out or what have you, it doesn't apply. And so now you want to be able to try to make some conclusions or judgments about the customers. If the columns that you're interested in exist for all of them, then doing an outer join might be fine, and then you could just do something like do some statistics on there and be able to make some conclusions. So all of these have their place, but it really depends on the problem you're trying to solve. Okay. All right. So this part here says preparing for coming sections. As I said, if we were in a day long, we would actually have multiple sections here in which we'd be doing these other things. Let me just draw your attention to them because there are things that you could try to tinker with on your own, or I don't know if we're going to, again, I don't quite know how things are going to be changed in the future. Actually, a number of these 90-minute or 2-hour reactors actually have a financial focus, things like Bitcoin and so on. So they're similar to what we're doing here, but the data sets are like financial data, like stock data and so on. But these two notebooks that are here, PCA is something called Principal Component Analysis. There's a lot of notes in there. Some of you may be able to go in there and work with the data and tinker around with it. And so it might be worth, for those of you who want to try to investigate this on your own. The third notebook is creating something called a receiver operating characteristic, which is a fancy term for how well your machine learning model is able to discriminate something. For those interested in the history, I think a receiver operating characteristic came from World War II. You had radar folks whose job it was to essentially look at a radar screen, and they were supposed to look at the blips on the radar screen and identify, is that a friendly or a foe, right? Is that one of our planes or is it one of the enemy planes? And the better those radar operators were at discriminating, the higher their essentially receiver operating characteristic. If you were guessing, you'd be only right half the time. But if you were really good at discriminating, you would be, good a lot more of the time. So this ROC notebook actually shows you how you can do that kind of computation on one of these machine learning models, which we haven't gotten to yet, admittedly. All right, so my apologies for making this longer probably than it was to be, but if people have questions, I'm certainly willing to, I'm going to look through what people have written so far and see if there's anything I missed. Okay, let's see. How to open the machine learning, making your data, which is just a text file on GitHub as a Jupyter notebook. Okay, so if you import Jupyter notebooks up to Azure, which you'll be able to do for the next few months, you can open the notebooks that way. There are other tools. So I would say, I'm just going to put this in the announcements here. It's possible to install Jupyter on your computer, and there's a couple options here. One would be, there's a really nice data science and machine learning distribution of Python called Anaconda. So if those of you who are here, some of you are here, are interested in pursuing this, you would probably want to go and take a look at Anaconda. Now, also Microsoft, now why can't I remember the name of, VS Code. Sorry, I was just blanking. Microsoft VS Code, you can also download. There's another one. It's a great IDE that runs on Macs and Windows and so on. If you download VS Code, you can actually follow instructions there to get the data science tools as well. I put Anaconda up here in part because a lot of people use it, frankly, and so if you're out in the world interacting with other data scientists or trying to become one yourself, it's likely you will see people using Anaconda, but that's free. VS Code would certainly be another strategy, and I have to say it's a great IDE. I use it for Golang, I use it for Python, and so on. And so VS Code allows you to download not only the data science extensions, but, and here's finally the answer to that question. VS Code will actually run Jupyter notebooks natively. So if you have VS Code installed on your computer and you have a Git repo that you have cloned that has Jupyter notebooks, your VS Code IDE can open a notebook and display it just like we were doing here. So that might be an answer as to why Microsoft is deprecating this cloud-based solution. They probably just don't want to expend the resources. They would prefer that you download VS Code onto your machine. It's free. It's a very robust and mature IDE. And so if you've got VS Code on your machine, you can view Jupyter notebooks. And I should have brought that up, but next time when I teach this on Thursday, I'm going to actually pull up VS Code and show you. It looks a little different. The API is different, or at least the way it's viewed is different, but it still allows you to natively view Jupyter notebooks. And there are more and more tools every day, it seems like, that will allow you to display and interact with a Jupyter notebook. Does that help? I hope. Okay, I'm going to keep looking for this and see if there's anything new.
Hey, James.
Yeah.
There's a question, follow-up question on that.
Okay.
They don't want to install, they just want to know what you've done on the server. I don't know if that helps.
I see. How did I do it on the server? Okay, well, I think what we did is, and you can even see on my project here, if you take a look here, you can see I've actually cloned it from, this is a woman named Sarah who works for Microsoft, and I cloned it originally from her project. So what I was having people do here in this class, if that's what you're asking, is that bit.ly link that I gave you goes to my project here. And then at that point, and if you did this while you were logged in as you, not me, you would clone my project, and then you would have your own copy of all the notebooks and the data in your own area on Azure Notebooks. Does that make sense? Does that answer what we were doing? So I mean, basically the idea is, this is a cloud solution that lets you do data analysis and so on. And so just clone somebody else's project, and then of course you can also create new notebooks and so on. You can also upload. So right here, there's an upload button. And similarly, you can download a project, get it on your own machine. So you can move it to some other platform, GitHub and things like that. So hopefully that answers the question. I think I understood that, I hope. Oh yeah, and also there is a survey, that link that was put in the chat. Please do fill that out, and any feedback that you can give us on making these better. Microsoft really takes this seriously. These reactors are free to the public, and the goal is to to really kind of help everybody learn and also use their tools too. But in the process, you get free knowledge. So anything you could put in here that would help us would be great. You didn't like this, he talked too much about this, he didn't talk enough about that, whatever, right? I mean, it's all going to be helpful information, so please do fill that out. Any other questions on data science, machine learning, the specifics of some of the tools? Or I realize we're at time now, but if anybody has any questions, and usually, like I said, when we do these in person, people hang around for a long time. We ask questions. They're interested in, as I said, becoming data scientists, migrating, etc. But if there are no other questions, let me just check to make sure I'm not missing anything. No. Okay. All right. Yeah. So great. Well, if there are no other questions, then let me just make sure. I don't think there are. Then thank you all for coming. I hope it was useful and informative, and certainly look forward to seeing you at future reactors, and also look forward to reading your feedback and helping us make this better for the next cohort of folks that show up. Thanks.